Yeah.
Hi everyone, welcome all to joining the today's webinar on Math Journey Behind Conventional Learning. My name is Ravali and I'm a part of team here at Turito. I'm joined here by today's speaker, Mr. Vasu and Ms. Priyanka from Student Counselor Department. This webinar is an outreach program by Turito for students to help in developing their learning skills and for parents who are willing to give their children best education. Before we start off, let me give a quick overview of our organization. And all you aware that Turito is an e-learning platform and our vision is to provide quality education to every student by well-experienced faculty. Currently, Turito is available in USA, Canada, Middle East, India, Singapore, and Australia regions. And programs offered by Turito are NAPLAN OC and one-on-one tutoring services for math, science, and English subjects in Australia region. And Turito exclusives are regular assessments to track the child progress and doubt clarification sessions for making their concepts stronger. And Turito provides parent access to because to make you a part of children learning journey. Moreover, we have top 2% certified educators whom we partnered with to envision our mission. And before getting into the session, let me give a quick intro about our today's speaker. Mr. Vasu is an international one-on-one tutoring head at Turito. He is a holder of Master of Mathematics and Bachelor of Education with a vast experience of 30 years in education industry. He is an IIT Foundation course content preparation expert here and also mentored 80,000 plus students for IIT and 4,000 for SAT and ACT scorers. And key aspects of today's webinar are understanding the why math concept and how mathematics is useful in real life and also how to learn as per the grades and trip and uh, Vasu sir will provide tips and tricks for improving math. Thank you, sir. Over to you.
Yeah. Thank you, Ravali. Give me control. You just exit.
Yes, sir.
Yeah. A warm welcome to everyone. Before we start up, this is the introduction to mathematics, a powerful tool that helps understand the world, encourages logical reasoning, critical and creative thinking, and powerful solving ability, global understanding and communication that organizes our lives and prevents chaos. As per mathematical inventions, they are numerous throughout the ages. Some of them were tangible, such as counting and measuring device like calculator, computers, everything. Some of them are not as tangible as methods of thinking and solving. These are not tangible. The symbols that express numbers are also one of the most important and mathematical inventions. Mathematics helps us to develop the ability to think. It helps us to explain how things work. It helps us to develop wisdom. It increases the speed of intuition in our mind. It helps to make the child smarter. Now, moving forward, this is the origin of maths. Mathematics originated from the Greek word meaning tendencies to learn. Multiple branches, numbers, geometric forms, algebra, and others. Mathematics has become the companion of man and his helper since the engineering of human existence on earth. When man first wanted to answer questions such as how many, he invented math. Then algebra was invented to facilitate calculations, measurements, analysis, and engineering. Trigonometry measured when humans wanted to locate high mountains and stars. So geometry was also very helpful in building structures. Animals count and use zero, they do arithmetic. So how far this numbers sense go in animals also. And then coming to mathematics in daily life, study of measurements, numbers, and space. Mathematics plays a vital role in all aspects of daily life. Examples: time tracking, driving, cooking, or jobs like accounting, financing, banking, engineering, and software. Mathematics is a pillar of organized life for the present day. Without numbers and mathematical evidence, we cannot resolve any issues in our daily life. There are times, measurements, rates, wages, tenders, discounts, claims, supplies, jobs, stocks, contracts, taxes, money exchange, consumption, etc. Everything. And in the absence of these, we have to face confusion and chaos. Then moving ahead, understanding the basic concepts in lower grades. Now we have the number system, which must be understood. Number system, actually you have the natural number system, whole number system, rational numbers, irrational numbers, together real numbers, and the biggest system, complex number system. We have algebra, geometry, and so on. We have many others. So here in algebra, we have the expressions, the equations, what is a variable, what is a coefficient, what is a constant. All this has to be understood in lower grades, in the beginning of the lower grades. And when geometry is introduced, they explain what is a point, what is a line, what is a ray, what is a line segment, what are angles, how they are made, acute angle, obtuse angle, right angle, straight angle. All these things are explained, and then comes triangles, quadrilaterals, polygons, squares, rhombuses, parallelograms, rectangles, circles, semicircle, and then they follow in higher grades as 3D structures, that is cylinder, cone, sphere, hemisphere. All these things will come. So this is all about algebra. So the basic foundations are very important in algebra. And then we have the arithmetic, where in arithmetic we use plus, minus, multiplication, division symbols. And then we have the other chapters related: fractions, percentages, decimals, ratios. Again, in ratios, we have direct variation, we have the inverse variation, and then the algebraic formulae. These are very important, like a plus b the 2, a minus b the 2, and a square minus b square. This is the difference of the squares. And then when you add a plus b the whole square plus a minus b the whole square, this is equal to 4ab. So here actually maximization and minimization can be understood. If the sum is given when the product is minimum, or when the product is given when the sum is maximum, this can be analyzed in lower grades. As you move on to the higher grades, now this concept can be analyzed in calculus, in maxima and minima. So this is how the chapter will be enhanced in higher grades. And some of the common math errors also can be understood right from lower grades. For example, a student will have a doubt whether 2 over 0 is it 0? It's not equal to 0. Or 2 over 0 is not equal to 2 also. Division by 0 is not defined. Even minus 3 square is not equal to 9. Minus 3 the whole square is 9, or you have minus 3 square is equal to 9. So here you have to watch the parentheses. Actually, this is not 9, this is minus 9. So you have to watch the parentheses, whether the parenthesis is beginning here, right from here, or right inside. So the parenthesis has to be observed. So these are the misconceptions. Even in exponents chapter, for example, x square the whole cube, this is not equal to x power 5. Or you see in fractions A over B plus C. This is not equal to A over B plus A over C. And you even have a doubt here in the lower grades whether when you divide the denominator, what happens? This is not equal to AB over C, because when you divide the denominator, it actually comes up, multiplies in the numerator. And then you have, if you something is dividing the numerator, uh, it is not like AC over B. Actually, the one which is dividing the numerator comes in the denominator and multiplies. Many misconceptions are there. X plus A the whole square. Is it equal to X square plus A square? No, it's not equal to X square plus A square. Even root of X square plus A square. Is it equal to X plus A? No, it is not equal to X plus A. Even 1 over X square plus X cube. It is not equal to X power minus 2 plus X power minus 3. This is also not correct. So they are not equal. So right from lower grades, when the mathematics is introduced to a child, he must understand what are misconceptions. What are the misconceptions I am doing it. So the subject, the basic concepts are very important as he moves from lower grades to higher grades. Now moving forward, how to develop skill in fast calculations. Now this is nothing but you have to apply speed drills. Speed drills are needed where addition, subtraction, multiplication, division. So when he is in lower grade, actually, when let us suppose he is in first grade, when he is understanding about numbers, what you will add to 2 so that he will get 10. What you will add to 3 so that he will get 10. Like that, the understanding can be enhanced to what you will add to 24 to get 100. These are addition problems. So lot of addition problems must be given after this. Go on with a random addition of different digits. And then, for example, let us suppose is adding 24 plus 86. So he knows that 20 plus 80 is 100. So 4 plus 6 is 10. He can write 110. So if addition process is done from lower grades in speed drills, if the student is given some assignments based on this, first in addition, then subtraction, then multiplication, then as follows, you can combine all of them also. You can have a problems based on addition, subtraction, multiplication, including the parentheses. So that's why PEDMAS is useful. So P is for parenthesis, E is for exponentiation, division, multiplication, addition, subtraction. So what first must be solved accordingly to this hierarchy? You have to maintain and you have to solve problems. So when speed drills are done with the student, he will get a very good knowledge of fast calculations. These fast calculations will be useful in competitive examinations like Knack plan or any other competitive examination. This will be very useful for the student. I'll tell you an example. For example, we are multiplying 25 into 15. So the common sense says 25 into 4 is 100. Now 25 into 16 is 25 into 4 into 4. That is 400. Now this is less by 116. Here it is 15. So it is 375. That is the understanding. Or for example, you have 25 into 30, let us suppose. 25 into 12 will give you 25 into 4 into 3, which will be 300. And 1 is extra, so it will be 325. That is how the subject must be understood. Now here, 6% of 50 is there. Now coming to percentages. Actually, we write 6 over 100 into 50. Why can't this be understood as 50% of 6? So this is 50%. 50% is half. Half of 6 is nothing but 3. Or for example, if you are writing 4% of 25. So here 4% of 25 can be understood as 25% of 4, that is 1. So just you can swap these numbers for your understanding here. So this knowledge, if you have, for example, this knowledge of fast calculations, not only in one chapter, in every chapter, where how fast we can do, that will be very useful for competitive type of examinations. Now moving ahead, understanding correlation in some concepts. Now actually here, some chapters can be correlated. For example, you have fractions, decimals, percentages. Now, for example, if I say 25%, it is nothing but 1/4. It is 0.25. If you are taking 33 1/3%, this is actually 1/3. It is 0.33 recurring. It is recurring. 66 2/3%. It is 0.66 recurring, or it is 2/3. So this correlation, if you can understand, in the previous problem where I showed you, for example, 6% of 25, of 50, let us suppose. So it is 50% of 6. If you know that 50% is half of 6 is nothing but 3. So percentage analyzed as a fraction, that will be very useful to solve problems fast. So you can be fast in higher grades. When you move, there is correlation between functions and calculus, vice versa. So what is this? For example, if you see a strictly decreasing function or a strictly increasing function, you will think that this is nothing but you can solve 1 function. So how to get a 1 function if you have a strictly increasing function or a strictly decreasing function? That observation you can do in calculus, where the first derivative, if it is greater than 0, it is strictly increasing function. If the first derivative is less than 0, it is a strictly decreasing function. So this is a higher grade chapter, calculus. In higher grades it comes. So these two are interlinked. Functions and calculus are interlinked. So you must know the correlation between the subjects. Even maximization and minimization, which I told you earlier. So in algebra you can do, again in calculus you can do. Even in calculus, for example, you have the maximization and minimization. That can be understood in quadratic equations, where how things are maximized or minimized. Now, moving ahead, need to have skills and short tips in some concepts. Now, here, for example, if I write a quadratic expression, x squared plus 10x plus 21, so the student must be able to factorize it directly by seeing the problem. Here, the coefficient of x squared is 1, or it may be different also. The coefficient of x squared can be different also. For example, if I have a problem like this. Now then, if the coefficient of x squared is 4 also, you must be able to factorize it. So this is x plus 1 times 4x minus 1. So directly if we can do, because this quadratic expression, it actually, because the coefficient of x squared, if it is positive, then the concavity will be upward for a parabola. This is a parabola, a second degree equation with nothing but, if it is equal to 0, this is a quadratic equation where this will become a parabola, and whether the concavity is upwards or the concavity is downwards, that has to be observed. And then where it is cutting, for example, this one is there. Here it is cutting at -7 and -3. So that the student will understand many things from this. If he is able to factorize it, he will know the distance between the x-intercepts which are formed. So many concepts, maximization, minimization. For example, this problem is based on minimization. What is the vertex of the parabola? Everything can be understood. Here also calculus is very easy to solve when you use calculus, all these type of questions. And analyzing equations. For example, you are given equations as a1x plus b1y equal to c1 and a2x plus b2y is equal to c2. Then these equations have a unique solution or an infinite number of solutions or no solutions. By seeing the equations, you can identify. This is a skill the student has to develop, and that will become a short tip to the student when he answers in competitive examinations. Even the direct variation. For example, I told you ratio, you have direct variation and inverse variation. For example, in 120 calories, the fat is 72. Then in 100 calories, what is the fat? So this is actually 72 over 120 you can write, and that will be nothing but 6 over 10. If you calculate, it will be 60 fat which will be present. So understanding the concept and what type of, see, from the concept only you can develop some short tips or skills to answer many questions in competitive examinations. And then moving ahead, how to prepare for performing well in competitive examinations. Now here you have mental calculations, gives the power to answer a question fast. within no waste of time you can answer, and eliminating options in a given MCQ. Now, see, first, the time management is very important. See, time management means here ability to finish off some problems within less number of time. What happens is the confidence builds in the examination and he can answer the other questions, which may be a little bit lengthy or having more calculations, application mode may be more. There he can apply some of, so he will get time to answer those questions. So some of the questions, if he is able to solve fast by seeing the paper, wherever the problems are easy, we're using mental calculations, we can directly get the answer. Those type of problems he has to answer and then he has to complete it. And then eliminating options in MCQ. For example, you have in MCQ, let us suppose you have 4 options. Now, you know very well that you get a decimal value. Let us suppose he has given here 0.81, here 1.2, here some 2.3, and here some 1.7. You know that the answer is a decimal, means that the numerator is less than the denominator, means surely this will be the option. So you need not calculate using the calculator or anything. Don't go with anything. So directly only one option is there. You can answer that option very well. So it happens in some problems. You can do those type of tricks and tips which you can follow and you can solve very well. Then moving ahead. Now understanding word problems. Now in word problems, first, data will be given in some problems where the data will be related to some questions. Either this can move with probability or statistics, or it can be algebra problem, and it can be a geometric problem. So geometry, you know very well that the figures will be given. You must be knowing the formulas, respective formulas, what is given. So first read the problem. Underline the constraints which are given in the problem. Let us suppose he says that the side of the square is 7 centimeters. Underline that part so that you will know what is given in the problem. And what is the question given in the problem, that also you must read it carefully, especially in probability problems when the data is given. He will be actually asking the probability of something with respect to something. So there you have to read the question probability. Otherwise, there is a chance that even a simple problem also you may go wrong. So word problems, when they are posed to you, so you must first read the problem, understand what is given in the problem and what is the question, and you have to move in the direction of what is asked in the problem. So you must have a bird's view of what is asked. So what is asked, what I must to do. So in order to get the answer, that you must need all this. For this, actually, you must know all the basic concepts, all the formulas, then only you will be able to understand this one. So first of all, in word problems, as I said, once again, I repeat it. So please read the problem carefully, understand what are given in the problem, what are the constraints which are given in the problem. Sometimes it happens to be that some constraints will be given in some problems where 0 less than or equal to x less than or equal to 10. X is lying between 0 to 10 and you are getting x more than 10. So that value doesn't satisfy. So you must be constraints also. You please underline what is given, the constraints in the problem. So if you underline those things, you won't go wrong. And the direction in which you have to solve the problem, think over it, have a bird's view of the problem, and then proceed accordingly. Moving ahead. Now, analyzing graphs. This is very, very important. In some of the countries, the 10th grade students also knows 3,000 graphs. Now, graphs are very important for a student. So graphs, actually, by seeing the graph, as I told earlier, by seeing a quadratic graph, you can say that what are the solutions of that particular graph. So by seeing the graph, you can answer many questions. So graphs actually includes line graphs. So straight line graphs. From this line graphs, you can identify what is the slope of the line. You can identify what is x-intercept and the y-intercepts. And sometimes one line will be given that is called as a line of best fit. Some points may not be on the line of best fit. They will be above or below. So some x-axis will be taken something and y-axis will be taken something. So let us suppose on x-axis heights are given, on y-axis weights are given of persons in a population. So a line of best fit will be given and accordingly the question will be answered. So graphical analysis is very important. It can be a line graph, it can be a bar graph, it can be a quadratic graph, it can be a exponential graph, it can be a logarithmic graph, it can be a trigonometric graph, it can be an inverse trigonometric graph. So statistics again has a bar graph. Again, in statistics, when they teach you about a median, you have a box plot. In this box plot, they will give you a mark like this. That mark will represent the median. Let us suppose this is 10. 10 is the median. So from graphs, you must be able to identify. Even more can be identified from graphs. Now, let us suppose you see cricket, let us suppose. In the first over, this is the runs which is made. In the second over, this is the runs which is made. In third over, this is the runs which is made. In fourth over, this is. So by seeing this one, by seeing the graph, you can say that in which particular over, the batsman has made a lot of runs or the particular team has made a lot of runs by seeing the graph. That is nothing but mode. So mode is nothing but again from statistics. So graphs explains many things directly. By seeing the graphs, you will be able to analyze the problems very easily and come to a conclusion of the answer, what from the graphs I can analyze. So graphs are very important. And even some graphs are there where, for example, I take an example of an absolute graph. Now, what will be absolute value of x plus 1? How the graph will be? What will be the absolute value of x minus 1? What will be twice of the absolute value? What will be absolute value of 2x? What will be, these are actually looks same because it's positive. Absolute value of x over 2. So this is the parent function. Or based on the parent function, how the graph moves horizontally or vertically. So that also you must know whether how the graph can move on x-axis or on y-axis, either vertically or horizontally. So these are also, so graphs actually explains many things. So you must know a lot of graphs and how to analyze graphs in competitive examinations. That is very, very important. Now moving ahead, how mathematics is made interesting. Now, see, giving real life example to the students. For example, you are in lower grade. Now, if you give an example to a student, then he will understand. Let us suppose that directly you introduce a variable, x is a variable, x takes some value. He will not be able to understand. So then you have to introduce the concept. Let us suppose one pen costs $5. Then 2 pence costs how many dollars? $10. Like that, the subject must be introduced. And if I take X pence, what is the cost? So it is 5x dollars. So introducing the variable or introducing any concept, well, let us suppose we have a concept of a times b plus c. This is called as a distributive property where multiplication is distributed over addition. Now this is a times b plus a times c. Now, this concept, when you introduce, give him an example. There are more varieties of examples which can be before the student you can put. For example, I have, this is 20 is the length and the width is 4, let us suppose. Now, you can have a break. Let us suppose this is 16 and this is 4. So the total area is nothing but you have two different areas. When you sum up these two areas, you get it. So here we are distributing actually 4 over the length. We are making it as a division of 16 and 4. So this will be 64 plus 16, which is nothing but 80. And directly also you can get 20 into 4 times is 80. So this is a distributive property where the length is made into 2 parts and we can show the distributive property. Or a simple example, let us suppose I am distributing 5 chocolates to a class consisting of 10 boys and 5 girls. Then the boys will get 50 chocolates and the girls will get 25 chocolates. So this is best distributed. Now, as you go into higher grades, now how interesting the topic is, this one. This is a fundamental principle of addition and this is a fundamental principle of multiplication. These are the two principles which are used in permutations and combinations. So in permutations and combinations, these are the two principles. And permutation and combinations are very helpful in probability also. In probability also, when the question is raised, permutation combinations will act. So here, fundamental principle of addition and multiplication, which are the two important principles for permutation and combination. Because a lower grade student will not understand permutation combinations. As he moves on to the higher grades, he will understand that this is what I use for distributive property. Now, let us suppose you are telling about commutative property, A plus B equal to B plus A. What is the meaning of this? It is nothing but whichever direction you add, the result will be same, 10. So this is how analysis can be made. Even say mathematics, how interesting it is. In lower grades, we teach when two parallel lines are cut by a transversal, these two are corresponding angles. Now the student is moving on to the higher grade. Now, when he moves on to the higher grade, he will know about parallel lines, and he knows that parallel lines, they have the same slope. When two lines have the same slope, the angles of inclination made will be same. So corresponding angles are nothing but the angles of inclination. And even in ninth grade, you have a theorem. For example, this is a circle, a tangent touches at a point. From the center, if the line drawn will be always perpendicular. Why it is perpendicular? For this, you have a theorem where the theorem analysis is made and everything is made, proof is made, everything is told. But a simple concept which you can understand is this is nothing but the line. From a point you want to reach the line, so that is nothing but the shortest distance, or always the shortest distance is perpendicular. So this is what mathematics can be made interesting by real life examples taught to the student and clarifying the doubts wherever it is necessary. So as then the teaching will be very easy for the student. And even a Turito teacher, for example, he will actually, the concepts will be given to the student by giving him real life examples, engaging the student with active teaching, and also having an interaction between the student, and a lot of misconceptions will be eliminated. Misconceptions must be eliminated. Otherwise, the student will be thinking whether I have to apply like this or like this. So there is somewhere there will be some of the other difficulty areas of the student where I can apply this formula or that formula. When to apply which formula, even though if you know the formulas, you will not be able in a position to apply all the formulas. So which formula you have to apply, where you have to apply, that also. So mathematical thinking is needed for the student. When he thinks, when he struggles for the problems, he will get the solutions. So the Turito teacher will, after teaching everything, if the problem is given to the student, he will see that the student is struggling to get the answer. So then he mustn't tell the answer. He won't tell the answer. He will tell you the direction to solve the problem. Then the student starts thinking, oh, this is the area where I have to think. So that's how he will develop thinking process. Moving ahead, now learn Max the Turito way. Learn concepts with real life examples, as I told earlier. So all the real life examples will be there. Engaging and active teaching and two-way interactions will be there, where the teacher, after introducing the concept, whether he has understood the concept by asking questions, by then giving a problem related to that particular question, and then asking him to solve some problems, giving assignments, all these things. Eliminating misconceptions. That's what earlier I told. Misconceptions, to say, as I told earlier, root of x square plus a square, whether it is equal to x plus a. So all these type of doubts will be eliminated, and building confidence and clarity. So when you can build up confidence, let us suppose the student, after the teacher has asked a question, the student and has answered it properly, then he must he must encourage the student that you are motivating him. So giving that you have done very good. So move ahead. Let us suppose a student has not done properly. He has made a wrong in a solution somewhere. Then without discouraging him, actually telling him where he has done mistake, identifying the mistakes is very important. See, when we have a failure only, we will think about how actually to overcome this. So get motivation for both correct and incorrect answers. So correct answers, you must applaud the student. And incorrect answers, these are not discouraged, but the direction where you were wrong, what you have to think. So eliminating where actually the student is failing, that is very important. And this is the fear of maths by building interest. So maths, has a lot of students has a fear in maths. So when the concepts are introduced with real life examples, when you are making an active teaching to the student, then he starts to develop interest in the subject. There will be some nexus, which will be some bondage will be formed between the student and the teacher, so that he will ask freely that I have a doubt like this, whether this is correct or wrong, whether I have to solve like this or not. So all these things are there. And to conclude, anyone can be a mathematician if one is given a proper guidance and training in the formative period of one's life. A good curriculum of mathematics is helpful in effective teaching and learning the subject. Experience says learning mathematics can be made easier and enjoyable in our curriculum if our curriculum includes mathematical activities and games. Mathematical activities and games are very important. Let us suppose if you have made it like a puzzle to the student, a problem, giving it as a word problem and puzzles asked, questions are asked like that, then that will create interest in the student to answer. And then emphasis should be laid on development of clear concept in mathematics in a child right from the lower grades. So that's what I was telling right from the beginning. The foundation must be strong. The basic concepts foundation must be strong for a student. And not only that, from the lower grades, as he move to higher grades, now where the emphasis is made. So it is believed that the process of learning is complete if your sense of hearing is accompanied by the sense of sight. By seeing the graphs, the figures, or in lower grades by seeing the pictorial things and accordingly understanding the subject. That is very important for the student. So thank you very much.
Yeah, sir. Thank you, sir. And let's move to Q&A session now, sir. And all the parents and students who joined to the webinar, please feel free to drop your questions at Q&A section, and we will go some questions, sir. And the first question is.
Yeah. Yeah, how to improve calculation speed? Is that the first question?
Yeah, yes, sir.
So as I said earlier, calculation speed you can improve right from lower grades. First, you take arithmetic, or that is addition, subtraction, multiplication, division. Individually, the student has to solve, and then again combining them and giving problems to them daily. So that builds confidence in him by, let us suppose one day is very good at calculation in that arithmetic, then you can give different types of questions. See that maximum word problems are also included for the student because the competitive examinations will demand word problems. So word problems means you must be fast in understanding the problem, read the problem, all these things are there. So that's why, so if you want to really improve the calculation speed, word problems also, because word problem has two, three lines of sentences will be formed. So reading the problem, understanding what is given, that is also helpful in higher grades. So as it moves from lower grades, so calculations can be made speed up by the speed drills, which I told you. Speed drills must be done with the student and then giving daily, let him solve some of the problems where the chapters are completed. Then he can do fast really. My child hates maths. How to make him get interested in the subject? So the best is to join with the Turito. That is my first answer because the teacher actually develops the concepts by real life examples. That is important because you can't just say that A times B plus A is A, B plus A is A, as I told earlier. So if you when you deliver a concept, deliver it differently by start with an example, create an example, create a real life world example, and then start introducing the concept. Directly, if you introduce the concept, the student will not be able to understand. And he thinks that Max is hard, tough. So Max is actually a language. It must be understood as a language. It communicates between persons. So it is fun. It is with puzzles. It is with games you can introduce. So let us suppose we can keep cards also. Let us suppose we have cards from 1 to 10. Then show to the student, is 1 is prime, is 2 is prime, is 3 is prime. So that is how the student will identify. It's like a game. So when they follow in a game, they will understand better. So that's how the subject interest must be inculcated in the student. How to build a strong foundation in maths? Any tips or strategies? So again, this is a question where, as say, right from the lower grades, first of all, when he learns about adding things, subtracting, all these things you have to build strongly. And then coming as he heads on to the higher grades, the subject will expand. So how is performing in the class, in the school, see, and then same model problems must be given with a little different problems also you can supply to the student so that he thinks. Never give a solution from your side or never ask him to see the solution so that let him have the struggle with the problem. So when he struggles, he will think in several directions. So I told earlier, mathematical thinking. So when he tries to think what I have to do, how to get the solution of this problem, then that will create an intuition in his mind and he can solve many problems. But before that, the basic foundation concepts must be known to a student, because even if you solve this many problems, 300 or 400 problems also, there may be some other problem which you may not get if the concept is not strong in the student. So building a strong foundation, for that you need the right from the lower class, the concepts must be understood by the student, and a daily practicing some problems which are related to his curriculum. That is very important. So then he will understand what is the subject and he will develop. How to introduce a max new concept to students? Yeah. So whenever you introduce a new concept, see that the strategy is, if you have a real life example, that is very good, because you can't just introduce a topic to a student, as I said earlier. So he must be having a real life example given to the student so that he understands the thing, and then ask him to give frame one problem based on that concept. When you ask him to frame a question, if somebody is asked to frame a question, rather than giving answers, framing a question is difficult. And when any student or a teacher, when he starts giving a question, writing a question, that he has to remember all the constraints in his mind and he has to create a problem. Say, for example, as I told earlier, one pen costs $5. What is the cost of 10 pens? That is a simple problem. Let us suppose I introduce another problem. Uh, there are some goats and there are some hens. They have legs, let us suppose. So if I give the sum of the goats and hens, and if I give you the number of legs which are there, so then he has to frame the equation. So how to frame an equation? So like that, he can take an example in his mind. There are 10 goats and 5 hens. So the total are 15. What is the number of legs he can calculate? And then he can frame a question. So framing questions will actually develop the mind like anything. So concepts, when they are introduced, real life examples, if they are there, that is well and good. And that is very necessary also. Otherwise, directly we can't introduce any concept to a student. So, and even sometimes a concept will be interlinked. So the basic concept, let us suppose in geometry, if you don't know, right, what is a right angle triangle, what is the use of telling Pythagoras theorem to you? So you must know what is a right angle triangle. Right angle triangle is a triangle where one of the angle is the right angle, 90 degrees. So that you must know. So the basic must be, then only you can understand what is Pythagoras theorem. So you must know what is hypotenuse. You must know what are the legs. So as the lower concept, right from the lower grades, the concepts must be digested, and then only you can move on. How should a child approach a new math concept? Will focusing on the concept help or practice more problems? Say, for example, let us suppose I explained you about a parallelogram, square, rhombus, rectangle. First, in these four, you must know what are present in all the four. That opposite sides are parallel. Then the diagonals, whether they bisect each other. In some of them, the diagonals bisect perpendicularly. So first, the concepts must be understood. Then only you can solve problems. First, understand the concepts, revise them properly, whether opposite sides are equal or all sides are equal, diagonals bisect perpendicularly or only diagonals bisect each other. So first, concept is needed for the student. Concept is not by hearting it. Understanding, you must have a parallelogram picture. You must understand, well, this is a parallelogram, opposite sides are equal. All these opposite sides are parallel. All these things he has to focus on. So he has to see everything, understand them, never by heart things. So understand them and then only go for problems. Otherwise, if you, without concept, if you solve problems also, that is sheer waste. You will not be able to solve more number of problems. Let us suppose if I give a small twist in one of the problem, he will not be able to understand. What topics are usually challenging for students and what must a parent do to help their child? First of all, in mathematics, I think this is a question on mathematics only. So you can't delete any chapter in mathematics. And even I can't say today that trigonometry is important, calculus is important. I can't say because algebraic formulae, if you learn, you can solve trigonometry. Some of the problems will be linked up with this. If you know algebraic formula and trigonometry, you can solve calculus and that too differentiation in calculus. Then integration, if you can solve only when you know trigonometry, algebraic formulae, and also differentiation. If you know all of them, including integration, you can solve differential equations. So never think that any part of math we can delete. No, never. So compulsory all the topics and the question says, must a parent to do help their, what must a parent to do to help their child? Yeah, it's a very good question. Ask the student to write a formula book by having all the formulas which is encountering in each and every chapter, maintain a formula book, and without seeing write the formulas and then having a correction so that he can eliminate all the mistakes. One day will come finally where he will not write a mistake. So without seeing, writing them and identifying the mistakes, where he is going wrong, which formula is not writing it properly, whether he didn't understand, identify them, and then giving some more problems to him, that is also very good. So a number of problems when he solves, he will be able to identify which problem is going wrong, whether the concept is not understood or whether he is unable to do that particular problem. Some process or some calculation mistakes are there by the student. All these things we can observe as a parent. And parent also must leave the student to solve the problem. Let him struggle, never give the answers. We as a teachers also, we do a lot of mistakes that we give answers in the last. But when the student struggles only, his thinking will start. So when the student thinks, then only he will get math, and math will become very easy for him. Can you suggest any activities to improve mental calculations? Yeah, as I said earlier, if it is a parent or a teacher who is concentrating on the child, if it is, I'll tell according to the parent. Parent has to give all speed problems to him. Let him give 18 into 11 is how much, 13 into 26 is how much. Like that, he can give many number of problems. Daily have a practice. Give the students some 10 problems on addition, subtraction in lower grades. And as he comes to the higher grades, let him think about the problem, read the problem, and can you calculate it without calculator? Can you calculate it mentally as a child? And to improve mental calculations, what you can do is, for example, you went to a grocery and you have purchased something from the stores and they gave a bill. Now get the bill to the house and then the last counting part you delete and ask the child to solve it mentally. That improves calculation. See, all these type of things, if you give, you will really develop. So daily you can either go with some assignments on problems, or you can do all these things with the child, mental calculations. So as I said earlier, 6% of 50, like that, I keep on asking the student many questions. So then he will be able to answer. That interaction also is very easy with the child. Please let us know some important topics in maths. So actually, that's what I told. There is no important anything in math. Every chapter is important. So if you don't know arithmetic, somewhere in higher education, you won't be able to solve. If you don't know algebra formula, you won't be able to solve a problem in differentiation or integration in calculus. Everything is interrelated. There is no important topics to a child. But see that the formulas are written in a book and practiced. And without saying he has to write them, what is the volume of a sphere, what is the surface area of a cylinder, all formulas. If the student practices and if he keeps a book, formula book, that is very important so that he can have a quick reference of the formulas. For every chapter, please write the formulas in that formula book so that he can just glance through and then without seeing if he writes, that is also very good. So there is no important topics in maths. Every topic is important. Everything is interconnected. You can't just leave any part of maths. Any daily tips to make child improve mathematics? Yes, it's a good question. I told earlier also, it all depends upon the student whether is in lower grade or a higher grade. If the student is in lower grade, have speed drills by giving those type of problems. As he moves on to the higher grade, revise the concepts, write a form, have a formula book, revise the concepts, and then see whether he knows the concepts or not. If he has not understood any concept, try to deliver that concept in a by showing some difference. Because the same way, if you tell him if there is any other way, try to introduce in another way, that will be making it easy. Because the same thing if you teach, he will not be able to understand, and again he will have that same confusion. So try to give it, see, because in mathematics also, we have a lot of ways in some concepts. We have 2, 3 ways of introducing the concept. We can introduce it to the child. Not only that, when problem solving comes also, we have sometimes 2, 3 methods of solving a problem. The school will be doing one method, but there will be some easy method where the student can do. First, tell him the school method, and then this method also, the other method also. If you teach, he must know all the ways of doing the problem. Don't think that only one solution must be there with the student. All the other solutions also, if it is there, sometimes in a different situation, so the other solution, the other method will be very useful for the student. So that's why show him all the various methods, all the different strategies to solve a problem. And then the daily tip is give him problems based on the chapter which is ongoing, and also the chapters on what chapters he has completed earlier. Otherwise, he will forget. There is a chance. So at least give him 1 or 2 problems from those chapters also. So if you make it consolidated, what happens is a student will not forget those chapters. There is a lot of things which happens in lower grades, especially when the student is doing one chapter, he will forget the other chapter formulas or the other chapter concepts. This is there. So that's why the ongoing one, you have to keep 1 or 2 problems from the chapters which has been completed. That will really give him a kick to him and he can do very well in mathematics. Is there any other question, Ravali?
No, sir. As of now, we are not getting any questions. And we will be ending the session now, sir. And thank you for explaining us with patience, sir. And we will be having a webinar in the upcoming week as well. We hope to see you all again. Until then, if you have any queries, please write to us at care@turito.com. For more info, please visit our website www.turito.com. And for better learning and better results, please join Turito. Thank you. Have a nice day.